Hi, in this video I will be explaining the main interfaces in Vivado that will allow you to write Verilog code to test. If you haven't already, I would suggest watching part 1 to this video, which explains how to set up a project in Verilog. I will be using an example project that I've previously worked on in order to show how to utilize Vivado's features to test your code. Firstly, the most important window is the Sources window, as this shows the hierarchy of Verilog files being used to contribute to the project. The file at the top of this hierarchy, known as the source, will be displayed in bold font. To view the code in your .v file, double-click the desired file in the Sources window. To the right of your screen, a window is now open to view your desired code. In this window, you can write Verilog code in order to be tested, as well as test bench and simulation files. To add a file to your project, you can either click the plus icon within the Sources window or select Add Sources under the Project Manager tab on the left of the screen. This will create a pop-up window for what type of file you want to create. A design source is either main Verilog code written to be run or a test bench file that can be used to test within the written Verilog code. A simulation source allows you to interface Verilog code written to a physical circuit board. Hit Next for what type of source you will be using. On the next screen, click the Create File button, which allows you to assign a name to your .v file. For creating test benches, it is useful to adapt a naming convention to separate Verilog code to run versus code to be tested. Once you have decided on a name for your file, select OK. Then select Finish, and your file will be added to the Sources window. You are then able to double-click this file to bring it up on the tabs to the right of the screen. Note that at any point, each window can be maximized to bring up a bigger view that can be useful in some scenarios. Once you have written Verilog code along with an accompanying test bench, you are able to run a simulation to view how information moves through your code, or, more specifically, how zeros and ones move through the circuit to see if the desired behavior has been successfully captured. Before running a simulation in Vivado, it is useful to understand how file hierarchy works. By right-clicking a file and clicking Set as Taught, the file will be treated as the main file to be executed for the project. For example, if your project contains multiple test benches for multiple modules, by setting a master test bench file as a top file, it allows you to simultaneously test multiple test benches. Navigate to the left-hand side of the screen and select Run Simulation under the Simulation tab. Click Run Behavioral Simulation. If your code has no errors, a new tab will open in the window to the right showing a timing graph of how bits move through your design code. To see the entire runtime of the circuit, there are tools you can use to adjust the frame of view. The magnifying glass icons above allow you to zoom in and out. The arrow buttons allow your cursor to move to the initial and final time of the circuit. The yellow vertical cursor can be used to view the values at a specific time of the circuit, which are displayed to the left of the window with the variable names that you previously assigned. This can also be accomplished by using the 4 arrow keys, up, down, left, right. You can also relaunch the simulation, which is useful after making updates to the test bench file, by clicking the circular arrow that appears on the very top interface in Vivado. Also located on the same interface bar is a button with an input box to specify how much longer you want to run the simulation for, which is very useful for more complex Vivado simulations. When you are finished with your simulated circuit and everything looks correct, it is time to synthesize your design. By synthesizing your design, your circuit undergoes the process of transforming to a gate-level representation from a RTL-specified representation. RTL stands for Register Transfer Level, and refers to the abstract circuit design that Verilog describes in its code. I will cover more on RTL design in my next video. This is the first step to ultimately allow you to implement your code onto physical hardware. Think of the synthesizing step in this process similar to building your code in an IDE like Visual Studio or Eclipse. Note that not always will your synthesis run without errors if your simulation was correct. This concludes a basic rundown of how to use Vivado to run Verilog code. In part 3, I'll explain more on the basics of Verilog coding. I hope you found this video useful.